What is green chemistry? There are so many principles of green chemistry. But in a brief, a few sentences, if I explain what is green chemistry, that reducing waste, minimization of waste materials, minimization of the pollution, prevention of pollution, all these aspects taken together, we call it green chemistry. So let's go ahead and understand what is that. What is green chemistry? It is a science that based on research towards the development of new sustainable processes. Now, what is a sustainable process? What is the meaning of sustainable? Sustainable process means that due to this process, our future resources should not be fully consumed. That is called sustainable. I think you have quite doubt regarding sustainability. I have asked so many students are getting different answers. Actually, sustainability means development in such a way so that all the resources will not be consumed in future and it will go on. Further, we will get our future generation also will get the resources. So we will consume that way. That means we use something renewable instead of non-renewable. So this is called sustainable. The future also should be sustained. So that is sustainable development, sustainable future, sustainable processes. Sustainable means keeping in mind the future, the next generation in mind. Now, invention, design and application of chemical products and processes to reduce or to eliminate the use and generation of hazardous substances. That means we will prevent formation of hazardous substances and we will not use any hazardous substances as far as possible and practically. That is called green chemistry. So in a single sentence I can explain green chemistry that prevention and use of hazardous and toxic substances. Prevention and use of hazardous and toxic substances is called green chemistry. The chemistry that is dealing with this type of things are called green chemistry.
Green chemistry to me means designing the materials and the chemicals that we will use in the future that are better for human.
Designing of chemical which will give less toxic materials. Using solvents which are less toxic. Alternative methods to prevent pollution. These are the major things. Okay. So principles of green chemistry. It is a set of principles that reduces or eliminates the formation of toxic materials and use also. Instead of non-renewable resources, we are using renewable resources. Principles. There are certain principles there. Around 12 principles are there, major principles. So, for example, using renewable feedstock, atom economy. Okay. So one by one we will be learning what are those. So these are the principles of green chemistry. Just have a look. Total 12 principles are there, major principles. So I'll explain one by one. First of all, prevent waste. We will go by a method, process, where formation of waste is prevented or as minimized as possible. Okay, like we go for recycling, we go for some sort of reuse, recycling, reduce, different techniques we will be using so that waste minimization will take place. And if waste generated, it will not be dumped, it will be somehow used as a raw material for some other product. So that is prevent waste. We will not allow the formation of any sort of waste. That is possible. Earlier days, waste was dumped here and there. But nowadays, the situation is so bad because the affluency of the people are using a lot of resources. So the waste material produced is also quite large quantity. So that we cannot just allow to dissipate in the surrounding. Rather, the waste prevention is the most important one. Prevention is always better than cure, So formation of or prevention of waste is the first principle. Second, atom economy. What is that? Atom economy means you are using certain reactant and how much desired product you are getting. The desired product should be quite high compared to the reactant that you have used. If the desired product quantity is high or good, okay, then it is following atomic economic principle. Atom economy, number of atom. You are taking some stoichiometric equation. The product form and the reactants that you have used, if the product form is in a quite good desired quantity, then waste minimization automatically will be there. So that's why it is called atom economy. Second principle. Now the third one. You have to go by alternate route. You may ask that how possible. It is possible by following certain alternative route. You have to go for different alternative route, go for research, find out what other route may be possible for same thing. Instead of using chemical, apply bacteria. So these alternative methods, sometimes bacteria methods can be far better. Not always. Most of the time we are using chemical because it is taking less time. Bacteria is taking much longer period, much longer time. That's why it is always not beneficial. It is not convenient. But sometimes it can be quite convenient also. Okay. So we are using into our daily life. For example, yeast we are using. Lactobacillus we are using. Doi bosano, lactobacillus, yeast for making bread. So you are regularly using bacteria, always not using chemical because these are food material and in the food you cannot use chemical. Chemical is not good for our body. So that's why as much as possible and practical you have to prevent using chemicals. Number 3, less hazardous chemical synthesis. As much as possible it should be less hazardous. Toxic material prevention is a must. Number 4, designing safer chemicals. If it is not available, you have to design new one. Designing safer chemicals. For the same purpose, instead of some toxic chemical, try to use some safer chemicals. Then you have use safer solvents. Safer solvent, for example, if possible, use water instead of organic. If not possible, use alcohol, but not hexane. See the difference? Hexane and alcohol. Maybe both the way you are getting the same purpose can be solved by using alcohol and hexane as a solvent. In that case, prefer alcohol compared to hexane because hexane is toxic to the environment. Hexane, if evaporates and goes into the air, is not good for health. So avoid hexane. Better use alcohol if possible. May not be always possible, but whenever possible, better to use alcohol instead of hexane. That is an example. So that I am telling safer solvent. Safer solvent. Carbon tetrachloride is not good. Chloroform, not good. So better to avoid this type of chemicals. Why? Because these are usually toxic. So if other solvents are available, better to use those. Chlorinated hydrocarbons as a solvent is toxic. Chlorinated hydrocarbons should be avoided. Chlorinated hydrocarbon, methyl chloride, methylene chloride, chloroform and carbon tetrachloride. These are called chlorinated hydrocarbons. So this type of solvent are avoidable. Then increase energy efficiency. Energy efficiency means what? You are using the energy as minimum as possible. You are supposed to use minimize the use of energy. Why? Because energy means fuel. Fuel means cost and pollution. Mind that way. Okay. But that whenever you are using energy, energy means it is related to some other fuel. Without fuel, energy not possible. Some fuel. So that fuel will create pollution and also as well as it will cost involved in that. Okay. So cost is there, pollution is there. So then as much as possible energy should be minimized. Now how possible? Use catalyst. Catalyst will reduce the requirement of energy. So that's why we have to use catalyst whenever required, whenever practicable, better to use catalyst. For example, we have to use some scents also. chemical sense. Acha, what is the melting point of sodium chloride? Tell me. Very common thing. Melting point of sodium chloride. Anybody can say? Sodium chloride is very common thing. What is the melting point? Any idea? 820. It's very high. Lot of energy will be required to melt it. But you need to melt it. Suppose required. Then how do you do it? Instead of using directly the pure material, you add something else like calcium chloride or magnesium chloride, add with it as an impurity. That impurity itself will reduce the melting point of sodium chloride. So that's a matter of common sense. Instead of taking the pure salt, add calcium chloride or magnesium chloride, a pinch. That will reduce the melting point a lot. So instead of 820, it will come down to 660. So obviously it is much more energy efficient. So that type of techniques you are supposed to use. That is all coming under the category of green chemistry principles. So why that is important? Earlier days it is not discussed also. In my time, when I was like you, means your age, so we have not heard about any green chemistry. I have not heard much about pollution. But why are people talking about pollution now? Because now it is going beyond our beyond certain range. Means it is actually becoming very crucial nowadays. Earlier it was not that dangerous. Dumping something in the roadside, that time was not so dangerous because the total population was less. So that earth could afford this pollution. But nowadays the situation is so worse that we have to take care of it. Okay, and there is a lot of movement also nowadays. Energy Swaraj movement. Have you heard about it? Energy Swaraj Foundation. It's okay. Some Mr. Solanki from IIT Bombay doing this movement. Energy Swaraj. It is called Only Earth or Single Earth movement type thing. Earth is only one. Na? We don't have any alternative planet. So if you just damage the whole planet, then there will be nowhere to go. Because Mars, Venus, nothing is habitable. So where do you go then? Other things are science fiction, not feasible still now. So Earth is the only planet we must protect it, is it? So that's why pollution prevention is required, and that's why green chemistry has come. Because chemistry is the only field that can prevent pollution. Other subjects are not related to this pollution, okay, much. Obviously it is a multidisciplinary subject, but maximum importance is from chemistry point of view. Then next is use of renewable feedstocks. Feedstock means it is a much better terminology for raw material. We are using the term raw material, na? This better term is feedstock. That is, we are starting as a supplying as a raw material. That is called feedstock. So renewable feedstock. If you use non-renewable one, it will be consumed. So your resource will be gone. So renewable should be there. So do you know all the metals that we have in the world are finite? Any metal, just name it. All are finite. Nothing is infinite. We are not making any metal. We are extracting from the nature. So in nature, the amount is always limited. And people are using enormously. So someday or some near future or far future, all the metals will be consumed. All the resources, metal resources will be consumed. So then what's the way out? You have to make it renewable. How? Reuse, recycle, continuous recycling should be there. So nothing is wasted actually. Metal damage means what? It is broken. If broken, you melt it, again you remold it. Quite possible. Instead of throwing it here and there, just remold it. Then nothing will be wasted. Actually nothing is spoiled in the world. So everything you can go on recycling. So that is, it will become renewable then. If you go on recycling things, then it will be renewable. But metal you can, more and more number of times you can go on recycling. There is no problem. But polymer, you cannot. Because polymer strength gets reduced. But metal, you melt, remove all the impurities, and again make it, it will become as good as new. Always like that. Any metal, even iron, if it is damaged, broken, you modify steel and then make new steel out of it. There is no difference with the virgin one. So, use of renewable feedstocks. Produce chemical derivatives. Reduce chemical derivatives. Means what? Whatever a side product or byproduct form, that must be reduced. You have to use a certain reaction, A plus B equal to C type, not say A plus B equal to C plus D. Got the idea? Addition reaction, type of reactions we are supposed to use as far as possible. A plus B equal to C. Nothing, no side product. If there is a side product, always not possible, sometimes there is a side product. If the side product is formed, that should be raw material or feedstock for another process. That way, side product or byproduct from one processing will go as a raw material for the next processing unit, then it will go to the next, and ultimately it will become a cyclic one. Okay? Product A, when you are forming, some product B is also there. Product B, you go to the next process industry, so that you get product C. Then product C may be producing something product D. So ultimately you get product A back. That sort of reaction should be always selected. It should be chosen. Instead of that you are getting something and other thing undesirable, discard. That type of process nowadays is not at all suitable. We have no such situation to do that luxury now. Understood? We don't have situation to do that luxury now. Earlier people used to, when you used to give some wedding house, we used to take food, whatever is required, okay, I am taking this much of, and after eating this much small, so the rest of the things just wasted. But nowadays, people have got a different idea. So buffet is for that. So you are supposed to take small quantity. You get it, don't be greedy. You get, okay, sufficiently. But after taking the first lot only, eating first lot, then you are taking the second lot. That is the better idea. Instead of dumping everything onto your plate, and after that you are not, you cannot eat that, and just dumping in the dustbin. And so many people is starving. Okay, that is totally undesirable, right? So another new system has come. Suppose your food has got excess. Now, if it is in a restaurant or hotel, nothing is wasted. Immediately, if it is not used or utilized, it will go into the freezer, and they are again using it in the next day. So you are not knowing also that same thing is supplied in next day as a new cuisine. So that is always there. Apart from that, that's a different story. Apart from that, there is another system has come nowadays. Suppose the food is already spoiled, you cannot eat. It happens now because of bad weather and all. The food has all rotten halfway, or bad smell has come. So nobody will take that because it will give disease also. So then what to do? If you dump in the dustbin, it will also create nuisance, create pollution. At a high pressure and temperature, this can be converted coal-like material. All the food is converted to some coal-like material, which can be burned afterwards as a fuel, producing electricity. Waste food also is converted to some coal-like material. Why you have to convert? Because otherwise it will not be combustible. So you have to make it combustible. By temperature pressure, it is converted to some coal-like material, looking like charcoal, and that is burnt again to produce electricity. Some different ideas I am telling you. Wastage is no way feasible nowadays. So then use catalyst. Always, whenever possible, better to use catalyst, because catalyst will prevent the loss, the wastage. Always it will prevent the loss or wastage, because reaction will be better, complete combustion, complete reaction. So catalyst will do these things, and as a result, better efficiency always obtained. So that's why use catalyst. Design for degradation, and real-time analysis for pollution. Design for degradation means what? Degradation is a must, but that should be also in a controlled way so that you can use. Degradation, what do you mean? Suppose you are having too much of tomato. You have a capacity to eat tomato. How much tomato you can eat? Sometimes in the seasonal time, the quantity produced is so high that farmers are not even picking up tomato from the field because the price has gone down so low that labor cost is more than the price of the tomato. And it happens for cucumber also. It happens for potato also. So what to do with that? Got the idea? Too much of production there, that is also bad for the farmer and for all, because it is actually wasted. You cannot use it. So from tomato you can use sauce, from potato you can use chips. So but that process industry, the system should be there nearby. Otherwise it will not be economical. Because from village to that processing industry maybe 200 kilometers away. So in that case, if you carry the transportation cost will be so high, practically it will be infeasible. And that's why people are not doing, because the labor cost is more than the cost of the tomato or cost of the potato. Then who will do that? Okay. So they let it dump in the ground and they are using it as a fertilizer. They are using the tomato and that cucumber produce as a fertilizer. Let it dump into the ground only, and while tilling it will mix with the soil. So sometimes people are doing like that also. So design should be there. Degradation also will have a design. What we can do? At least we can produce alcohol out of that. By degradation of fruit, we can produce alcohol. That is design. And that alcohol can be used as a fuel along with the petrol. That is called power alcohol. Isn't it? So this type of design should be there. And European people are doing that design very nicely. Because things are very costly. Our production is much higher. But the proper management is not there. You need to do the management, and that management may be available into some city, not there at every villages. And that's why that village people, they are always getting affected economically. Okay, farmers are getting affected economically because these things are produced which could be used quite nicely, but could not be because there is no that type of infrastructure. Next is real-time analysis of pollution prevention. Some pollution if created somewhere, okay, you have to have some sensor that will measure the H2S formation, the ammonia formation. Okay, the sensors will measure, and the sensor will send the data to the control unit that here this pollution is happening. So you can take care of the problem. So that is real time, means always, every time. Whenever is forming, immediately the data is sent. So that is called real time analysis. Then and there it is sent. So real time analysis. Achha. Then inherently safer chemistry for accident prevention. Safer chemistry for accident prevention. Okay. So use less temperature, less pressure, and then condition will be much comfortable. Otherwise, there can be more accident. High temperature pressure, whenever you use, there is a much more risk of accident. But low temperature pressure, if possible, with catalyst and all, that is always better. Maybe initially the investment cost will be a bit higher, but in the long run it will be beneficial most of the time.
When we say green chemistry, we mean environmentally friendly chemical processes and doing chemistry with personal safety and the environment in mind. There are 12 principles designed to help make chemistry greener. We will discuss each of these 12 principles with an example.
First is waste prevention.
A simple concept. If you keep your room neat and tidy, you won't have to clean up as much. If your room gets really messy, then you will have a lot to clean
Acha, I'm telling it will be faster. So what he's telling that you have, suppose if you just dump things into a room, it will be easier. Dump your bag, your pen, pencil, book, everything into a room. It will be quite easier. But after that, making it order will be very difficult. But instead of that, from the beginning if you do it, keep it in arranged fashion, then never will have to do it again. So your books are in a proper place, your garments are in the proper place. If you actually do that from the beginning, that is waste prevention. Don't allow the generation of waste. Okay, if you don't allow the generation of waste, then waste is not formed. Then why to talk about the waste? There will no waste at all. That is called waste prevention. Is it possible? Yes, it is possible. Why not done? People are not concerned earlier. People used to take the easier thing, just like dumping everything into a room. That is easier. So people used to do that because that problem was not there, that acute. Nowadays system is becoming more serious. That's why people will have to become serious. Okay, and that's why this first is waste prevention. Don't produce waste at all.
If we prevent waste from being produced, then there would be less to clean up. Now, this is all
Less waste, less to clean up.
to have zero waste for any given
Zero waste is impossible.
On
Okay.
a global scale, the beauty of this principle is that it can be applied to almost every single chemical reaction conducted. For example, polystyrene is a fossil fuel derived polymer used to make all disposable cups and packaging material.
These things are all made of polystyrene, and this polystyrene is produced by petroleum. That is, petroleum oil, the derivative. We are making the polystyrene. Okay.
Materials. The polymer itself needs to be expanded before it can be used in packaging. Traditionally, this was done with CFCs or chlorofluorocarbons, which deplete the ozone layer. Now, this is done with carbon dioxide waste from other industrial processes. Instead of releasing carbon dioxide into the atmosphere and contributing to the greenhouse effect,
Carbon dioxide is a very good solvent. Carbon dioxide is a very good solvent. So instead of releasing carbon dioxide in the air, if we can use it as a solvent, then it is utilized and pollution is prevented. Both the way good. But how can you use gas as a solvent? You are not using gas. Using oxygen in the cylinder. You are using that cooking gas. We are handling so many gases. So why not carbon dioxide also? Why we allow it to go into the air? Rather you use it, store it into a cylinder, and then carbon dioxide can be used as a solvent, very good solvent, but with a certain amount of pressure. And already carbon dioxide, if it is stored into a cylinder, that is under pressure. So when you open the nozzle, the gas comes out as a liquid. So you can use it as a solvent.
this is contained and used to expand polystyrene. So there is no additional carbon dioxide being released into the atmosphere.
So if it is used as a polystyrene for formation, carbon dioxide is used instead of CFC.
This principle encourages design and
Could you follow
hazardous
what is the first principle telling? Could you understand? So as a solvent, we were using earlier chlorofluorocarbon, which is quite bad. Why? It is chlorofluorocarbon mainly it is a problem, ozone layer depleter, not for greenhouse gas. Mainly it is because of ozone depleter effect. So that's why it should be prevented. So if you want to prevent using CFC, then what you will be using? Carbon dioxide is the solution. Carbon dioxide we are always generating this way or that way. That instead of releasing in the air, stored it into a cylinder and can be used as a solvent. Carbon dioxide is used as a solvent. CFC is also a gas, carbon dioxide is also a gas. Why don't you use carbon dioxide instead of CFC? That alternative. Okay, that thought process is different nowadays. Thought process is different. Earlier people used to use CFC because it is non-toxic it is some sort of gas which is non-combustible. Okay, but carbon dioxide is also non-combustible. Carbon dioxide is also non-toxic. So why don't you use carbon dioxide instead of CFC? That's the idea. Alternative is always there. You have to find it out. It is not that always it is necessary. Toxic things can be removed or alternative can be found. You have to find it. People are finding now. Earlier people not giving any attention in these things. Now they are giving attention. That is the thing. So green chemistry has come new because the necessity has come. Otherwise why people will do? Whatever cheaper people will do that. Right? But now it is becoming necessity. That's why people are doing it. Less hazardous or toxic chemicals. Less toxic.
Chemicals. In research and chemical industries, drug developers always look towards using chemicals
Designing
that are
safer
higher
chemicals.
into molecules that have a particular shape. This minimises the unwanted side effects that some drugs can have. Think about it like a pair of gloves. The right-hand glove can only fit over your right hand, and the left-hand glove can only fit over your left hand.
This is explaining the chirality. Molecules are having chirality, na? So left hand, right hand means what they are telling, that your left hand is just mirror image of the right hand. So the molecules are also having that. One molecule is mirror image of the other molecule. So maybe one particular chemical, instead of using this type of chemical, some chiral molecules can be used. And chiral molecules are having a speciality. It will react with very specific manner. And wastage is minimized. Instead of using chemical, if you use biochemical, example, enzyme. So if you use enzyme instead of ordinary chemical catalyst, the advantage is that it will always act as a stereoselective process. Stereoselective process, do you understand? Stereoselective process. As a result, the waste is minimized and the efficiency of the reaction is more than 90% always. And all the ordinary chemical reaction, efficiency 50%, 60%, 70%, not beyond that. But more than 90% efficiency you are getting with enzyme. Then why don't you use enzyme instead of chemicals? This is the thing that people are talking about. So designing safer chemical means that. Make some chemical which is stereoselective or stereospecific. Then this stereoselective or stereospecific one will give better reaction, better efficiency. Cost, well, if you are not using in a large scale, it is costly always. If you are using in a very large scale, it will be always cheaper. A very common example, you go for a Xerox photocopy. Okay, one photocopy will take how much? And if you take 100 photocopy, it becomes cheaper. So here is also like that, everything.
Industry is trying to produce medicines whereby 100% of the drug produced is chiral. This fulfills another rule of green chemistry by minimising the amount of unwanted products, i.e. drug substances.
Particularly what I told you, that is applicable for medicine and drug. Medicines and drug, a particular chiral molecule is very much effective, other one is not at all effective. So normally what we are doing, suppose D product and L product. One is D and another is L. Dextrorotatory and levorotatory. My medicine is dextrorotatory. Levorotatory also will be produced in general if you use chemicals. So dextro, levo both will be produced. But we need dextro only. After that separation is also a huge problem. Dextro and levo, because both are most of the properties are same. Boiling point, melting point, most of the properties will be similar or very close. Then separation will be a real difficult job. Instead of that, if you go by a process where only dextro is produced, that is stereoselective one, and that will be the best.
About chirality, carefully tweaking parts of a drug's design can also be useful, as drug designs can be used to target specific organs, making the drug less likely to have unwanted side effects.
Your side effect also will be less because you are taking exactly the real drug, the other one, the impurity is not used. Acha, by the way, you have heard about generic medicine? Sunecho? Platinum RX, group ache, apps ache. So, what is the difference between generic medicine and branded medicine? Branded medicine, the company is giving guarantee that this particular thing is there. And generic medicine means that thing is there. But is it 100% pure one? That's a doubt. Okay, because nobody is giving guarantee to a generic medicine. Generic medicine, that particular drug is there. Suppose paracetamol, okay, it's giving paracetamol. But along with that, there are other impurities also, which can be bad for the health. Which can be bad for health. Because the purification needs lot of cost. So you can, if you can remove that cost, the price will drop down to half or 1/3. That's why there is sold in the market by half price or 1/3 price. Because purification is not done. That is the main difference between the branded medicine and generic medicine. People are thinking that generic medicine, why to buy the branded medicine? There is a trend nowadays, স্বল্প মূল্যের ওষুধ নাকি কি বলে ন্যায্য মূল্যে ওষুধের দোকান শুনেছো? Okay, so what is the main difference? Purification. Otherwise same medicine but purification is not purified. Along with the drug, we have other impurities also. So cost automatically will be less because the purification cost is enormous. You know the ordinary water, distilled water price, enormous difference. So here also the drug you are not separating. So without separation you sell it, and then some of the impurities will be still there with that. It may be bad for the health. Maybe, may not be always, but sometimes it can be bad for health. That you don't know what medicine you are taking, right? Antibiotic medicine you are taking, antibiotic is more dangerous. So you are taking one antibiotic, you have the other replica, that mirror image. That mirror image medicine may not be a medicine, it can be toxic one, but it is there along with this. Got the problem? That is the trouble.
The next time you look at tights, certain paints, or even plastics used in window frames, you may want to think about the raw materials from which they are made. Do you know any of these materials? Pause the video, think, and resume when ready. If you said nylon for tights, you'd be right. If you said polyurethane, you'd be right for paints and coatings. Finally, plastic window frames are made of PVC. These contain a plasticizer, allowing the frames to be easily molded. All of these materials.
By the way, do you know plasticizer? That's why I need to explain each and every line of it. Just I cannot show and leave. So these three things it is shown. One is nylon, another was polystyrene, and last one is PVC. Every polymer we are using a material called plasticizer. That plasticizer is a chemical that will make the plastic soft. Otherwise it will be hard and brittle. So to make it soft and delicate, flexibility, not delicate, flexibility. To make it flexible, we are using a chemical that is called plasticizer. Different type of plasticizer can be in use, but these are oils sometimes, but that oils are not edible oil, non-edible oils. They are plasticizer. So these are hazardous. These are bad. So alternatives can be possible.
Require lactic acid in their production. Usually, benzene
Acha,
is used to.
this adipic acid is a raw material for nylon. How he is making it? Question is how we are making it. This adipic acid is not naturally available. It is not available as a adipic acid river. There is no adipic acid river. So how do you make it then? By chemical synthesis from benzene. And benzene is highly toxic. Benzene is highly toxic. It is carcinogenic, cancer causing. So that's why it is bad, no doubt. But how do you make the adipic acid then? Nylon is required. So adipic acid required. There is alternative way. From sugar we can make it. Just see.
This compound, but unfortunately, benzene is carcinogenic or cancer-causing. Instead, glucose and special
Glucose.
enzymes
Use
extracted
glucose
from genetically
instead of benzene.
modified bacteria can be used to produce adipic acid. What do you
Same
think
adipic acid is produced. Okay, same adipic acid is produced, but instead of benzene, we are using glucose here. That type of idea, get the idea that actually what can be done. Instead of the same adipic acid as a raw material we need for the preparation of nylon, but instead of benzene, we can use glucose and enzyme. So the whole process will be becoming non-toxic, non-hazardous. because glucose is a food, enzyme is from bacteria. So these things, and all these bacteria are not pathogenic bacteria. So these bacteria and glucose, if you this type of things you use zymase enzyme, that glucoamylase, alpha amylase type of enzyme, if you use, then it is totally safe. Because these are biocompatible things. So it will not give any danger to our health, and we are supposed to use this type of things instead of chemical, avoid chemicals.
This way. Pause the video, think about this, and resume when ready. An answer is that glucose is harmless and is essentially sugar.
Glucose
So
spelling wrong.
conducting the synthesis in this way protects the workers
It is
who
harmless.
produce this compound by coming into contact with carcinogenic benzene.
Total 12 principles. This is fourth one.
Chemical reactions often need a solvent.
So just let's revise the first three. This is the fourth one. So what are the first three? First one, producing minimum waste, as less as possible. Producing minimum waste. Then second one was using less toxic solvents. Instead of CFC, we can use carbon dioxide. Less toxic solvents. Then safer chemicals. Designing safer chemicals. Maybe you have to make it. Not available ready-made. But you have to make it in a way so that it is a safer chemical. These three steps we have learned. Now fourth one is safer solvent.
We take place. Can you remember what a solvent does? Pause the video and continue when ready. The answer is that a solvent will dissolve a solute. This means that two or more soluble compounds may then react with one another to form a new product. The issues are that a lot of chemical processes involve organic solvents, that is, those containing carbon and hydrogen, and sometimes halogen groups. Organic solvents are usually obtained from the fractional distillation of crude oil. This is an environmentally unfriendly process which uses a lot of energy and produces greenhouse gases. Also, the solvents themselves are usually environmentally unfriendly and need to be disposed of carefully. Chemists around the world are looking towards green chemistry and the development of safer solvents. It may sound surprising, but these safer solvents include special forms of water and carbon dioxide, which exist in a supercritical state. Essentially, this means at a certain temperature, these solvents will exist as a solid, liquid, and gas simultaneously. You may be wondering why this is important. The reason is that non-polar compounds, traditionally needing organic solvents, can be dissolved in a safer solvent. More importantly, carbon dioxide and water are not flammable, like most organic solvents, and are very easy to obtain from other chemical processes. Imagine, instead of releasing carbon dioxide into the air and it contributing to global warming, we can collect it and use it as a solvent instead. This has been especially useful to the dry cleaning and textiles industries.
Most often,
So what is the fourth one? Safer solvents. Safer solvent means, okay, instead of releasing carbon dioxide in the air, if you can use it as a solvent. How it is possible? Stored into a container. And then with pressure it will be liquefied, and that liquid carbon dioxide is a very good solvent. Like from carrot you can make carotene. From carrot, the carotene, beta carotene, you can take out by this solvent extraction process. From neem leaf, you can the chemical azadirachtin can be extracted and bottled. Okay, there is another different type of herbs actually. Basil. So tulsi pata. Instead of buying Sri Tulsi and all, we can prepare at home very simply. So easy. But you cannot boil with water. If you boil, all the good property is lost. It is damaged. Then you have to use solvent extraction. But normally we are using some, if you use some organic solvent, the problem is the solvent itself will be toxic. You can use alcohol maximum. You can use alcohol. Alcohol is not that toxic. Alcohol is not toxic, so you can use alcohol, but for extraction. Next is part 5.
chemists find themselves working with many
Risk of
dangerous
accidents.
chemicals
Minimize
and
the risk of
dangerous
accidents.
processes. Can you think of any reasons that chemicals or chemical processes that could present a danger to workers in this field. Pause the video and continue when ready. The main reasons are that the chemicals used to make the product could be very toxic, explosive, or corrosive. And it's not just about the chemicals.
Acha, hazardous. What is the meaning? Hey, what is the meaning of hazardous? Na, bolle hobe na. Hazardous, there are three properties. One is toxic. Right now it is shown and asked immediately. It was shown right now. One is toxicity, reactivity, corrosivity. These three properties, if there, we will call it any of the three, not all three together. Okay? And explosive nature also. Fire hazard. Fire hazard is also a hazard. It can give fire hazard, risk of accident. So, corrosivity. Corrosivity means it will damage. Reactivity. It is highly reactive. It may react in the gases in the air also. That is also undesirable. Okay. So reactivity, corrosivity. I just kept my personal experience. I'll tell you. One beaker full of concentrated sulfuric acid was kept somewhere because the bottle was somehow required and it was poured into some beaker and it was kept like that. Sulfuric acid has a property, it absorbs moisture from the air. As a result, it was full up to the brim. So it's collected from moisture from air and it overflowed. The sulfuric acid overflew and it was spreading the whole table, damaging the whole table. That's a personal experience I'm telling you. It happens. By chance, if you make the mistake, it will happen. Accident. I'll give one personal experience. One 5-liter barrel was kept into a laboratory. Concentrated sulfuric acid. It was bought, it was supplied by the supplier and it is kept somewhere. What to do? Just kept as it is. Okay? I am not doing any mistake also. After a few days, it is found somehow the container, there was a crack. It happened by chance, by accident. So the whole area got damaged. So it is called corrosivity. Practical experience. Corrosivity. Earlier one, what I told? Reactivity. Corrosivity, reactivity, toxicity, and explosive nature. These 4 types of hazardous things are there. Hazardous. This is called hazardous. Any of the 4 there, we'll call it hazardous.
Some chemical processes require high temperature and pressures to produce certain chemicals.
High temperature pressure is always
Such
bad.
temperatures and pressures have been known to cause fires, explosions, and serious
It can cause fire,
chemical
explosions.
plants. Minimizing the potential for accidents has been written into the mantra of green chemistry by using less harmful chemicals and or reducing the amount of heat or pressure a chemical process requires.
So,
Catalysis.
minimize the risk.
Do you remember what catalyst does? If so, pause the video, say your answer, and continue to see if you're right. The answer is that catalyst increases the rate of the chemical reaction. This means that desired products can be made more quickly by using a lower energy pathway. As well, the catalyst is regenerated, so it can be reused over and over again. However, despite these advantages, do you know of any disadvantages to using catalysts? Pause the video, think about this, and continue when ready. You might have said that catalysts can often be expensive, in some cases made of toxic metals, or in the case of a biological catalyst known as an enzyme, it can be very selective about the chemicals it's exposed to and might only work in a narrow temperature range. Often, metal catalysts are used in drug design and ensures that a chemical adopts a particular chirality. Yet enzymes or biological catalysts provide countless examples of being able to fill the same role as a metal catalyst. The key advantage of enzymes are that the reactions can be performed under aqueous conditions and at ambient temperatures. In industry, desulfurization of fuels by catalysis is used to reduce atmospheric sulfur. Can you think why this might be important? Pause and continue when ready. The correct answer is that sulphur, which ends up in the atmosphere, can contribute to acid rain. Therefore, better catalysts are being developed to remove sulphur from fuels to prevent atmospheric issues later. In addition, the development of fuel cells is leading to better electrocatalysis. This is to improve the efficiency of the redox reactions that take place in these fuel cells, so that they don't have to be recharged as often.
So, what is the takeaway from this? It's called takeaway. After just observing this, what we could understand? Tell me the gist, summary. What you have understood from this particular last one? Catalyst, what is the benefit? It will give the faster reaction. Achha. Now, chemical catalyst, so far people are using chemical catalyst. The problem of chemical catalyst is that normally high temperature, pressure, all these things are required. Even though you are using catalyst, still temperature, pressure is required. Without temperature, pressure, chemical processes industry not possible. So instead of chemical process industry, convert it into biochemical process industry. Okay, so that is a much better idea. Maybe in a day it is not possible. You have some chemical process industry, suddenly you cannot switch off everything and start a new. Not possible. But slowly we can do it. Same process chemical in process industry. Next unit, when you are just going to put the next unit, instead of chemical process industry, put it a biochemical process industry. The same thing will get with a much better benefit and with a minimum risk, hazard and pollution. Risk is also there, not only pollution, there is a risk also. There can be fire, there can be accident, any type of leakage. You obviously you have not forgotten about Chernobyl disaster, you have not forgotten about this Fukushima Daiichi. So many accidents, isn't it? Bhopal gas disaster, have you forgotten? Bhopal gas disaster? That's a very bad thing happened. So many people died, so many people became crippled. Okay, so obnoxious gases coming out. Just think about the chemical industry. Is it good? Lot of chemicals, fumes coming out. Avoid. Slowly go towards green. Okay, green means always not the color. Green means towards the eco-friendly system. From eco-unfriendly to eco-friendly. Switch over. In a day, not possible. But well, new engineers are supposed to do it. So you are the upcoming engineers. So you also have some responsibility.
One of the biggest challenges that chemists.
But nobody told that we are computer engineer, how we can do it. Huh? You're supposed to say that, huh? We are computer engineers, how we can do the prevention of pollution into the industry, right? But who is doing all the software of this control system? Who is making the software? Well, tell me. Who will make the software for the process control industry? Industrial process control system. Who will make the software for that? You will be making. So you also can take part into that, directly or indirectly. You can take part in reality into the society, social problems. You can take a particular role. At least some role you should have. Everyone has small role, it will become huge. So all the computer engineers also involved, okay, into this industry. Without this computer engineer also, industry is not possible nowadays. AI, ML, required, na? So computer engineers are also involved in that. Don't think that we have no responsibility, so we are quite away. Not that. Now, real-time analysis of pollution prevention. Let's come to that point.
Is knowing what impact their synthesis is going to have on the environment. Monitoring a process on a small scale to see what pollution is produced at a particular stage of a reaction.
You have a monitor, and in that monitor there are ups and downs going on. CO2 gas emission, SO2 gas emission, everything real-time data it is supplying. Who will do this analysis? Software engineer. Better software engineer. This analysis will be done by software engineers. Okay. This machineries will make by someone else, electronic engineers. So this is really a multidisciplinary subject. This is really this particular subject, environmental science, is a multidisciplinary subject. All different from sectors, engineers and everyone required, even doctor. Because if there is this toxic effect, so what is the remedy? Who will say? Doctor, isn't it? So doctors and all engineers will be required, including computer engineer.
Can reduce the pollution that's produced in the large-scale synthesis. Can you think how? Pause the video and continue when you're ready. An answer might be that looking at the pollution produced on a small scale and in real time will enable chemists to know where they have to change in their large-scale synthesis to ensure their practices have a lower environmental impact.
Many chemical processes are designed to be as efficient as possible. There are many reasons why this is done. Firstly, it is very costly if a chemical synthesis is not designed to be efficient. In industry, chemists are aiming to modify or develop reactions so that they will proceed at ambient temperature and pressure. This is because it costs energy to produce both high and very low temperatures. The 2005 Nobel Prize for Chemistry was jointly awarded to a group of chemists who developed an energy-efficient catalyst for a high atom economy reaction, so that it was able to proceed at a standard ambient temperature and pressure. Recall that a high atom economy reaction is one that uses all the atoms in the reactant to create the product or products. The reaction is called the metathesis method and is responsible for the synthesis of many polymers with special properties, additives to polymers, and fuels, and biologically reactive compounds such as insect pheromones, herbicides, and drugs. So far, many of our plastic products are derived from crude oil, which is a non-renewable source. We cannot grow or produce crude oil. This means
We cannot go for a plantation of crude oil. It is showing, huh? Showing very interestingly. See, we cannot go for plantation of যেমন টাকার গাছ লাগানো যায় না তখন তিলের গাছও লাগানো যাবে না ঠিক it is showing that way.
Instead, we must wait millions of years in order for dead carbon-based living
একটু
organisms
পরে
to be compressed by layers and layers of sediment before we get crude oil.
let it finish and
So
allow it to
renewable
go for 5 minutes.
refers to raw material that can be grown or produced by humans. The usage of renewable feedstocks.
What is the meaning of renewable feedstock? The raw material that we are using should be renewable instead of non-renewable. Just like crude oil, we are using so many ways that polymer raw material is what? Petroleum. From petroleum only we are getting naphtha. Naphtha cracker unit we are getting polymer globules. From polymer globules we are making polymeric materials. This is the way. So we cannot produce it by any sort of plantation. We cannot produce any oil. So this type of practice should be avoided. Slowly we should go away from this petroleum products application because we are utilizing petroleum products enormously everywhere. That is avoidable. Better to go for other alternatives, whatever available. Okay. So that is called renewable feedstock.
Half the waste produced in crude oil refinery and distillation processes. Most printer inks are made from crude oil-derived pigments.
Crude oil undergoes distillation. Lot of cost involved.
On a global scale, this can be a problem in the long
What
run.
is this? Printers. Printing ink. So far, hey, listen. So far, for printing ink into a printer, what we are using? This is your point of interest. Computer engineering. Okay? So printer is also a part of computer. So in the printer, this ink that we used to use, earlier it was from petroleum products. But nowadays, instead of this, we are using corn juice. Corn juice is used. That is an alternative, which is renewable.
Currently in development are soy-based inks, which are derived from the oil of the soybean plant.
Soya
As a
based.
plant, soybean
Soybean oil,
is a
soybean.
resource. The production process of these inks is overall more environmentally friendly than their petroleum-based counterparts. Also, these soy-based inks are much brighter than the petroleum-based inks. The recycling process of paper products printed with soy-based inks is also considerably more environmentally friendly. When paper products are recycled, the ink needs to be removed. Petroleum inks can be difficult to remove, but soy-based inks can be removed with relative ease.
I think this pronunciation you cannot understand. I am just telling you what last sentence told. Hey, listen. What last sentence told? Soya based ink, soya means soybean. That soya based ink, if you use, then it is easy to remove from the paper. So that paper can be recycled after bleaching. But this petroleum based ink, if it is printed on the paper, difficult to remove. That's why people cannot reuse the paper. Recycling not possible, and as a result, the paper is used to make packaging box. Got me? That paper cannot be recycled. Then what you are doing that? By using that you can make packaging box, but not paper again. But if you are using soya ink, then you can recycle the paper and make paper out of paper. That is the betterment. This is the beauty of the renewable feedstock. Design for
Whatever
degradation.
waste is produced on a global scale, unless the waste is recycled, it fills up in our landfills, destroys habitats, and will be a very serious health hazard. Imagine if one day the waste that we produce can be naturally broken down by microbes in the environment or dissolved.
Microbial degradation design.
This principle explores such a concept. Ideally, whatever we use and throw away would present no hazard to the environment and would not accumulate in landfills. If you've ever had to get stitches because of an injury, the stitches slowly dissolve over time. This is in fact a polymer called polyglycolic.
You have heard about this material stitch? Polylactic acid thread. Polylactic acid thread is used for stitch to give the stitch. Nowadays, not like earlier. Earlier that stitch you have to cut the stitch. Nowadays you don't have to, because after stitching, slowly it will mix up with your skin. Because this polylactic acid is the organic material which will be easily degraded. So that is the design for degradation. It is designed in such a way, it is degraded into the body, and afterwards you don't have to take the pain of removing the stitches. It is also painful. Removing the stitches is also painful. Nowadays it is totally gone. Now, how cesarean is gone nowadays, done? You have heard about the cesarean operation. So, for newborn babies, the cesarean. So, how people are nowadays doing? Giving some sort of gum, adhesive. Okay? No stitch, nothing. Adhesive used. And that adhesive is biodegradable adhesive. It is mixed with the body and slowly it will be totally mixed with the body. You will not feel anything afterwards. It will be totally stretch mark free. It will be for any type of operation there will be some mark, na? So that mark also will not be there if it is that type of adhesive is used, which is bioadhesive. Polyglycolic acid, polylactic acid, these type of materials are used. Okay? You can go for a few minutes. You can take a break.